our next speaker, Bahjat Kawar. It's work with Shiran Zada, Oran, Omer, Chang, Tali, Dekel, Inbar, Mosseri, and Michal Irani. To joint work with Weizmann Institute and the Technion and Google.
All right. Hello, everyone. My name is Bahjat. I'm a PhD student at the Technion, and today I will be presenting the product of my internship at Google Research, Imagic text-based real image editing with the diffusion models. So I'm going to start with basically the talk of the town right now, diffusion models. They're these wildly popular generative models. And the way they work is that we start from a completely random Gaussian image like this one, and we iteratively denoise it little by little until we get some generated image. And the way to train these models is actually pretty simple. We just train a simple denoiser. We train for a simple denoising reconstruction objective. Now, say that I don't want this completely random generated image. I want to specify what I want to be generated. So as a human, the most intuitive way to describe what I want to see in a generated image is using natural text. So say I want to see a photo of a red car. I can just ask the model to do that. We utilize the large language models as text encoders, and we just simply condition our diffusion model on this text embedding in order to get a generation that gives us what we want, a photo of a red car. And these models are also trained in a simple denoising reconstruction fashion. Only this time we need a data set of text-image pairs to train them. All right, so what we wanted to do in our work is take these models that know how to generate these complex concepts and use them for image editing. So say, for example, I took a photo of this dog using my phone or my camera. It's a real photo. And I want to edit it so that the dog is sitting. So any dog owner would probably sympathize with the problem of that your dog doesn't really do the pose you want for the camera. And notice that here we only have a single real image as input. We have our text, and the editing task is kind of complex. We need to know which dog we want to edit, how to move it inside the image and change its pose so that it is now matches the text, it is now sitting, and also fill in the missing parts behind the original pose of the dog. So we need to preserve the background and also fill in the blanks. And our question is, can we use these text recognition diffusion models in order to achieve that? And the answer is yes, we can, and we did. As you can see here, we preserved the background, we preserved the identity of the dog, and we made him sit. So the way we achieved that is it's a three-stage algorithm, but it's actually pretty simple. We start from the same reconstruction loss for text condition diffusion models. We take the image, we add noise to it, and we ask the diffusion model to denoise this image, returning back to the original model, to the original image using a simple reconstruction loss. Only this time, what we want to optimize is the text embedding that conditions the diffusion model. So because we only have one input, one input text, the text that describes the target edit, a bird spreading wings, we just use it as an initial guess, and we backpropagate through the diffusion model to optimize this reconstruction loss on the text embedding. We want to optimize the text embedding so that we look for an embedding that describes the contents of the image. So after this, we get an optimized text embedding that describes this image. So for example, if we try it on this cake image, and we take this optimized embedding and pass it through a diffusion process, what we get is an image that somewhat semantically resembles our input image, but isn't an exact reconstruction. So that's why we take this reconstruction loss, and we take this optimized embedding, and we further fine-tune the model in order to better reconstruct the image using this optimized embedding. And after this step, we actually get a good reconstruction, an almost perfect reconstruction of the image. And now we get to the final interesting part, the editing. We just take this optimized embedding that we obtained, and linearly interpolate it towards the target text embedding, a bird spreading wings. And we take this interpolation, we pass it through a regular diffusion scheme, only using the fine-tuned model, which contains some information about the image. And this is how we obtain this same bird, only spreading wings. Okay, so just one thing about the interpolation. In order to linearly interpolate, we need to know how intensely to go between the optimized embedding that represents the image and the target text embedding. So if we look here, we have this cake image that we want to turn into a pistachio cake. If you look at the bottom row, you can see the image as a function of the interpolation parameter. As we increase it, we go more towards a pistachio cake, more towards the text, and less towards the original image. On the top row, we see the same process for the original diffusion model without fine-tuning, which shows why fine-tuning is necessary, because it gives the diffusion model an idea of what the image should be, and it is able to generalize into preserving the characteristics of the original image while still aligning with the text, and not just completely transforming it into a different pistachio cake. All right, so this was how our method, which works actually like magic. That's why we call it image magic, Imagic. Let's see some cool results. So if we want to make these two parrots kiss, we can. Notice how we preserve the identity of the parrots and also the background while still aligning with the text. We can have this person give us the thumbs up. Notice the complexity, the non-rigidity of these edits, which Imagic is actually the first to present such a method that can edit images in a way that move them in the image and preserve the overall content. And of course, if you don't like vanilla cakes, we can always turn it into a chocolate cake using only a single image and a single target text. So we took this nice tool, Imagic, and for the dog image, we tried to generate it, edit it in a different position so the dog can sit, jump, lie down, maybe play with a toy or a frisbee. Notice how in all these settings we preserve the background, we preserve the identity of the dog, while still aligning well with the target text edit. You can also do the same thing for this person picture, where we can do a variety of hand positions, even sometimes adding an object, such as the cup here. If you don't like dogs, we also have cats, so we can add a variety of different items to the cat, a hat, an apron, and even turn it into a drawing. Same goes for the horse, which can turn into a zebra, give it a saddle, or turn it into a cartoon. And this is actually pretty nice that we can do both style edits, such as turning a photo into a drawing, and also do non-rigid complex edits, such as having the horse with its head down. We also experimented with applying Imagic on a variety of text-based edits, so I will highlight a few. So on the top, we can see turning a day photo of a beach to the photo of a beach taken at night, a drawing of a watermelon, so that's style edits. We can also edit the color of the shirt. We can duplicate objects, such as in the example of the banana. We can also, as we saw before, change the pose of objects. We can edit multiple objects in an image. In short, it can do anything you can describe with text, which is pretty cool. And just so that we understand what is the task being solved here. So let's try to have a thought experiment. Let's look at this bird image. I want to ask each one of you to try to imagine it spreading its wings. I'm pretty sure that if I ask everyone what they're thinking of, we're going to get different variations, right? Naturally, if I want to edit an image using only a target text prompt, I could get multiple options for the desired edit. Because of the stochasticity in diffusion models, we can do the same process, get an optimized embedding, fine-tune the model, and then just try different random seeds for the edit, and we can get different variations of the same edit. So you can see we preserve the bird or the composition of the image, and all of these images are valid solutions for a photo of a bird spreading wings. And As you can see, it can be in different settings, different options. Same goes for this forest photo, where if we ask children to draw the forest, each child will, of course, do it differently. That's why we have art projects. So the diffusion model is also good at this variability in the results. Now, I mentioned before that we just linearly interpolate between two text embeddings. So if we look at the stages of this interpolation, we notice that the movement is smooth and semantically meaningful. So let's take a look at this chair, which turns into a wooden chair. You can see the stages along the interpolation trajectory. It's just a linear line in the text embedding space, but it has very interesting implications in the image domain. Same goes for the blue car, the red car that changes into a blue car. We can see all the color changes in the middle. And same goes for the flowers that turn into tulips and back. So I would like to thank my collaborators on this work, starting with Shiran and Zada, who helped a lot on this project. Oran Lang, Omer Tov, Weizmann, Chang, Tali, Dekel, Inbar, Mosseri, and Michal Irani. Thank you a lot. If you want to check out read more about our project, you can check out the project webpage in the link and in the QR code. And there's also, very interestingly, just a little while after we released the paper, there are these great people at Hugging Face, which already released an unofficial implementation using Stable Diffusion. So if you want to play around with the code, you're very welcome. Thank you for listening.
Thank you. We have time for questions.
Thank you. I wanted to ask about the diffusion model. Did you use the stable diffusion? And about the process of finding the text prompt or text encoding. And this backpropagation could be very heavy. Can you tell us how long or how heavy is this processing? How long will it take to create new images?
Right, so in most of the images we see here, we actually used Google's Imagine model and not Stable Diffusion. But we also had some experience with Stable Diffusion. It works there as well. It takes approximately 7 to 10 minutes for each edit, the entire process. I'm talking about the optimization of the text embedding and also the fine-tuning of the diffusion model together. It's kind of a slow process, but there are works that attempt to accelerate it. This is on one TPU, yes.
Any more questions? Okay, so let's thank the speaker again.
Thank you.